What's up, everyone? In today's episode, we're talking about a huge CO2 emitter, which is concrete, right? It's one of the world's most used building materials, but it produces a lot of pollution. And the problem is concrete floors need a lot of reinforcement, and they use a lot of material to keep them from cracking. In today's episode, we're talking about some awesome research that leverages the secrets of origami to create an awesome structure that looks beautiful, uses less material, and is better for the environment. In today's episode, we're talking about an awesome zigzagging construction method that makes construction greener. But before we dive too deep into that topic, I want to first start with today's sponsor, Mauser Electronics. And if you've been rocking with us for a little while on the podcast, you know we're excited about Mauser because they do a great job at communicating trends in technology in a way that's concise and easy to understand in these awesome articles. And if you're saying that sounds familiar, it's because it's exactly what we're trying to do in the podcast format. So that's why we like working with them. But we're including a link to an article in today's show notes, which is a perfect connection to today's topic, which is about the key to renewable energy. And it talks about how energy storage is critical, mainly because of the intermittency challenge, which basically means that all these renewable energy sources, particularly wind and solar, have intermittent power output. So you need to have local storage solutions to support the grid and ensure a consistent power supply. I think it's super interesting. And, you know, when you talk about the future of buildings and the future of infrastructure, you're going to be looking at this smart grid with either battery storage, hydro or thermal, some new generation version of storing electricity at the usage location and kind of overhauling the grid, so to speak. And I think that's an awesome segue into today's topic, which is also about the future of buildings.
Dude, absolutely. Yeah. One quick note before we move on from the grid stuff. One of the reasons I love Mauser is that they know how to make things that are just uber relatable to the average Joe. And I feel like electric vehicles are like taking over the world, and the stress that's going to have on the grid is really going to need this advancement, this evolution. And they've just done a great job of breaking down everything that's going into it in this article. So I just wanted to give my official Forbode Golden Star recommendation for the folks listening. I know, it's a big one.
Official gold star.
Those are rare, hard to come by. But yeah, definitely check it out.
Awesome. All right. So again, back to the main meat of today's episode. The topic is around construction. Mainly with concrete and cement production, driving tons of emissions. And concrete is the world's most used building material. Mm-hmm. But as I alluded to, it produces a lot of pollution. Around 8% of global CO2 emissions come from producing cement, which is the key ingredient in concrete. Mm-hmm. Just as a note, like everyone out there that thinks the U.S. is a huge country full of lots of people with lots of industry and lots of emissions, the global cement production total surpasses the total emissions of everyone and everything inside the United States on an annual basis. So concrete is a big deal in terms of CO2 emissions and protecting our environment. Part of the issue there is that concrete floors require tons of reinforcement inside, and it uses a lot of extra material. So lots of steel, lots of concrete is used to build structural concrete that's strong enough to withstand the elements and strong enough to withstand stacking stories upon stories, floors upon floors.
Now, why is that? We got to take a step back to sophomore year of undergrad, right, Daniel? We're going to solid mechanics with Dr. Knudsen.
Let's do it.
All right, so concrete is commonly used, like you said, in construction. And when it comes to compressive strength, like things... If you want to build a pillar out of it, it's fine. If you want to make a beam out of it, on the other hand, like kind of what you would use for a walkway, it just completely crumples. And that's where the rebar comes in for extra reinforcement so that the concrete can essentially like solidify around it.
And you use the steel then to support it from a shear and tensile strength perspective, right?
Mm-hmm. Correct. So now you have... typically additional concrete that's needed to be poured, just generally to support the beam itself. But you also have the extra manufacturing strain on the environment and, the general electricity consumption, et cetera, to add those steel beams for reinforcement. So not only do you have the bad concrete, but you have extra cost added on as well.
Yeah. And so let's get to kind of the solution, or what we're talking about today in terms of new technology. I gotta check this name again. A PhD student at ETH Zurich, Lotte Scheder-Bieschen. I hope I said that correctly. She created a reusable foldable mold to vault concrete floors, which, you say vaulted, like I think of like a nice fancy vaulted ceiling. But when we're talking about vaulted, it means with using an arch shape to help support the concrete. Changing the shape of the mold in which the concrete is poured can fundamentally change the strength of the concrete. So as opposed to pouring it in regular rectangular prisms like we're doing in our floors right now, reinforced by steel, by adding in geometry like folds and arches, you can actually create a concrete structure that's stronger, with more structural strength, with more tensile strength, and it uses less material than the current production methods, which is, feels kind of crazy. Like, how haven't we done this before? But, how haven't we done this before?
Well, it reminds me of like old churches that you see from like the Gothic era, where the load of the ceiling is distributed on these arches and stuff, and the walls weren't load bearing. And it feels like in a similar way, I mean, instead of being the ceiling, now this is used for flooring. The load is being distributed almost strategically to these different points on the concrete floor, so that it leverages that incredible compressive strength and it minimizes the concentration of shear stress. So,
well, and it
all
also,
the new connected is what I was getting from this article.
Yeah, I'm with you, and I want to harp on that point as well, because vaulted ceilings in old churches, like, that's honestly one of my favorite parts about traveling to new places. Is Nelly and I love to duck into old churches, because in a lot of areas, like, the older buildings have been knocked down and replaced by new buildings, but when you travel anywhere, usually churches have been preserved, so you can step into an old church that was built 700 years ago, and you can look at the architecture and you can look at the way that it was built, and usually they're beautiful inside and well maintained. But we love stepping into churches. Usually when we're walking and exploring a new city, if there's a church that's got the doors open, we're going to step in real quick and take a look.
Love that.
It's very similarly here, right? You look at, and we're going to include the link in the show notes. Everyone should check out the photos on this article in the show notes, but specifically the YouTube video. I think it describes it really, really well. But these vaulted curved ceilings using curved crease folding like origami, they make everything stronger without adding weight, but it also looks way more beautiful than our current industrial buildings. So I think you're onto something here, right? If we've got the opportunity to make buildings that are stronger, buildings that use less material, in a cheaper and easier manner, with a lower carbon footprint impact, and they look better, it's something that I'm definitely super excited about.
Dude, me too. And one of the things that I thought was interesting is that apparently this idea of creating complex geometries with concrete to improve performance isn't really new. It's been done before, but the downside has always been that, you need some sort of mold to pour the concrete into so that it can set in this shape. And the molds are generally made out of styrofoam, which is like petroleum based. So it goes against the green eco-conscious mentality they're going after here. Or, you can make something that's made of sustainable material, but it's going to be sacrificial. So it's a one-time use. And that's where we start to get into the bread and butter of what the folks here have done. And I'm not going to steal that from you. I'm going to let you spill that secret sauce.
Well, and I there's one thing I want to mention here is, like, we're going to mention origami. As a part of this, I'm going to mention origami. But I want you to go check out the video in the show notes, because it's not origami that, like, a golem like me can't figure out. It's like the origami that, like, I figured out as a kid when I was, like, fiddling with a piece of paper. Like, this is something that's easily, it's not a super complex geometry. It's actually the simple, beautiful geometry, which is part of what makes it so awesome that it actually works.
Yeah.
Imagine you fold a paper back and forth with some zigzags to make a fan. I don't know if you've ever done that. It's something that, like,
every time
I used to always do in
class.
church growing up with the church programs. If I got bored, like, fold them into a fan and then start fanning myself. If you like fold these papers in a zigzag to create fans, this is essentially what they're doing here, but they're using around 4 of those fans to create like a matrix where you have the they're not trusses, but you have the vaulted arches of the concrete geometry kind of extending down into each corner, and then it's like a big arch in the middle, and it's got zigzags on it, and it is beautiful. But the way that they were able to make this light, reusable, sustainable, is by using thin wood strips with strips of fabric as the hinges, and it unfolds like a fan into this strong zigzag shape. The prototype, I think, costs $720 per fan, and they were able to make it with a stapler and a simple template. What's crazy is Lotte, the researcher, the PhD student, did this all while she was 8 months pregnant. She was able to demonstrate that it's super light, super easy to handle.
That's badass.
She said it can be.
I don't know how else to say it.
Yeah, I mean, what a killer. I mean,
yeah.
I guess in this case it's not a killer. She's producing life, but she's also producing incredible ideas at the same time. She was showing that it can be built by anyone, even without their training. And essentially, she did this at a scale model. It cost around $720 per fan. And she was able to demonstrate that each of these, at the scale model, right? Each of these molds only weighed around 24 kilograms, but could hold up to 1 ton of concrete. After the concrete dries and sets, the mold can be removed from the concrete, and it folds back up and can be used again. So it's reusable. It uses simple materials like textiles and plywood. Doesn't require these complex molds that are made out of styrofoam, and or are one-time use, which would kind of defeat the purpose of it being a green technology. And in this case, I want to harp on it again just because it's so awesome. She was able to achieve this all and demonstrate it all while she was 8 months pregnant, which is pretty awesome.
Dude, absolutely. And in the linked video, they show how easy it is to put it together and take it apart. And I think that really adds to the superpower of this offering, right? Like, not only is it affordable, not only does it not weigh a lot, but it's really easy to put away and bring out whenever you need it. So imagine if you're a construction crew and you have an array of these things for, I don't know, different places and settings that you want to set up a concrete floor. Super exciting.
Well, and I want to highlight here some of the objections that I started to have in my head looking at this. Like, it looks like it may require non-traditional geometry for like a normal office building, which, you know, may make it harder to adopt, or you have to design around the geometry of like having curved arch ceilings and maybe a higher distance between each floor. I'm not sure if it requires that, but I could see that.
I don't think I agree with you on that, actually.
Okay.
At least based on the video they were showing, right? Like, my takeaway was that instead of having a, I don't know, 10-inch block of concrete, now you have it hollowed out. And the top where, you know, it's going to be the flooring is still flat. You put on your traditional flooring material, and the floor underneath, what is it, the usual tile covers that we put on in offices? You can still mount those without any issues.
Drop ceilings, yeah.
The drop ceilings. Yeah, you can still mount those without any issues. So I don't think it would...
I guess my concern is, I don't know, like, and this is purely imaginary here, but like, is the distance from the top of floor 1 to the top of floor 2, the walking surface, is that going to be higher using this because you need the arch geometry as opposed to using flat steel beams? Do you know what I'm saying? I guess if you're going to build a building that's 100 feet tall, are you going to be able to get less floors out of it because of this? I'm not sure.
I don't think this is targeting applications where you would already be using flat steel beams, though.
Well, that's what I was going to say, is I started to get concerned about that. And then I started to notice that, you know, the focus here was around like building affordable housing and affordable public buildings, not skyscrapers.
Bingo. Yeah.
And one of the biggest impacts, which I thought was exciting, was around training programs to provide the designs for the molds and circulate those in areas where locals don't have the ability to build strong enough buildings with concrete and steel beams.
Mm-hmm.
I think she tested it in South Africa. They were able to do it with bioconcrete, where the additive was made, instead of having just gravel added to the concrete, they added shredded plants to it to increase the strength.
Reinforcing it. Nice.
They were able to teach locals to build their own. The plan is to circulate, like basically all you need is fabric and wood. You can create these molds, and then using concrete, you don't need as much steel to make your buildings. You can make make concrete buildings with less steel, less pollution. It's lower cost. It's easier to manufacture. And Lotte, the researcher here, is even designing a market hall in Cape Town using this system. And her plan is to take the company, I think it's called Unfold Form, bring Unfold Form to the market.
I'm all for it, man. And another place where my head was going is, I think one of the first episodes we did on this podcast was about 3D printed homes, using 3D printed concrete. And it just made me wonder, there was a development in Austin where they really took it seriously, like trying to make high-end homes using 3D printed concrete, not just, small homes and little, secondary units that you put in your backyard.
Accessory dwelling units.
ADUs, there you go.
ADUs, yeah.
Yeah. And one of the biggest challenges is still that you can make the first floor using concrete, but then if you are going to make an upper floor, it has to be traditional. And this just made me wonder, like, if they start honing in on geometries that are perfect for molds to set, is it possible that they can feed that knowledge into these machines that are doing concrete 3D printing so that they can start layering bit by bit and optimize that approach?
That sounds really interesting. And it kind of like applies, right, with some of the 3D printed geometry we've seen, where to reduce the amount of material, instead of just laying straight lines, they're using corrugation. It almost looks like the cross section of cardboard is what they're doing with 3D printed concrete. It's a similar principle here, right? They're using the zigzag, but instead of trying to provide strength in the vertical direction for load bearing walls, they're also able to solve the equation for horizontal building as well, to create the support for floors, right, to build stories on top of each other. So I'm with you. This is really interesting. I don't know. What do you say? We wrap it up here?
Yeah, send it.
All right. Well, everyone, concrete is strong, but it's also wasteful. And it's a shame because it's one of the most common building materials in the world, creates a ton of pollution. But a PhD student at ETH Zurich found a better way. She created a zigzagged mold that's cheap, easy to build, can be used anywhere, and it basically uses accordion folds, kind of like if you folded a paper fan. This foldable wooden mold fans open, holds tons of concrete, and then once the concrete is set, it folds up for reuse. It essentially allows people to build buildings and build floors, multi-story buildings, with less pollution. It works anywhere, even in low resource areas. And one of my favorite parts about it is it makes the buildings look more beautiful. You've got this awesome arch shape, like vaulted ceilings with the cool accordion zigzags. It almost looks like a piece of art. But in this case, the art is also working to make the construction process greener and, more accessible to folks in low cost areas.
Dude, I love it. Spot on.
Thanks, dog.
All right. I think that's it. That's the pod.
Yep. Peace.